Hi everyone. In this video, we're going to see how large language model LLM, in our case Llama 3.2, can be used to explain what is the core principle on which the transformer based models are designed. They are usually designed to give a next token in an auto-regressive way. That means, suppose I give a code, for example, say I get it from this database, and I will go up to here, then put it into the autoregressive. I'll put here, and it will complete, be the chain you want to see. If I put this, it'll give the completion. So it uses a transformer based model, which is shown here. I have a different video which explains thoroughly what is a feed forward, what is attention layer, multi head attention, and how they are encoding and embedding everything, right? All are there, and also positional encoding, why it is required. And this model was designed after we found limitations in RNN, recurrent neural network. They were not able to scale well for a large application. So that's why this was designed by Google team, and it uses very novel techniques so that it can be parallelized. Components in the this model can be parallelized so that we can use large number of GPUs which can run parallel, and using positional encoding, we can get that position information which was lost during the parallelization. I will explain in a different video, and I've this paper. This is a landmark paper. Attention is all you need. It was like a breaking point. Earlier, we were running RNNs. We were not able to get a good performance. This paper by our Google team really changed that. All the GPT, whatever LLMs you see, they're all based on this. Let's go back to our autoregressive stuff. So it says that it finished. Be the change you want to see. This is from Mahatma Gandhi, and it also gives additional information. So it does the basic job of completing the given sentence. Suppose I want to use this one LLM for, we call it a chain of thought reasoning. That means if I give a library has got 240 books and each shelf can hold up to 60 books, how many shelves I need to buy or how many shelves I need, then it has to do um, chain of thought reasoning. And this also from um, came from a original paper uh, by Google team. I have explained here what is this, etc. Here, if you look at it, chain of thought is a Google Brains paper. This actually made a lot of advances in, instead of just doing next word prediction by LLM. Now it can do some logical processing, right? You give them, it will use a chain of thought, give a information like what I was talking about. Let's go back here. I believe it is here. So if I give a chain of thought example, let us see the library has got 240 books and each shelf can hold up to 60 books. How many shelves I need to buy? Let's ask this LLM, right? Let's see how it comes back. And so this one, Llama 3.2, is got the capability of doing chain of thought. We call it a COT, which I explained. So it came up beautifully. Number of books, 240. So it goes one by one, chain of thoughts. Number of books per shelf is 60. Okay. Number of shelves is equal to number of books divided by, and we get four shelves. So you need a four shelves. It's perfectly right. So now this is the COT, and there are other options, other advanced ones, which I explained here, and React, and Salesforce agent force uses React. Here, I will have a separate video on explaining React and tree up thoughts. Tree up thought is something like this. You can you have an input and it can take a tree form, like how human brain works. You'll have a branching, and basically you'll follow the tree, and finally it'll arrive at the output. These are all the very important concepts which now LLMs are enhanced to do this work. Originally, they were designed to do finding the next token for a given sentence. Now, they are enhanced for tree of thoughts and COT, chain of thoughts, and also the React one. So I will have a separate videos for React and tree of thoughts, and in that video I will give some examples on how LLMs work on that given logical problems. And as I said, React is the base foundation um, for our agent force. Again, React also was invented by Google folks. I've given some references here. The React is done by Google team as well as Princeton University. This paper, given a link in there, the agent force paper, it explains clearly of it. So I will explain in detail in another video. Hope this is useful. And I also want to say that I keep a catalog of data to train the LLMs, and I will also have a video which explains how to create the LLM yourself. If you have quite a number of clusters of the GPUs and you are willing to run them for days or months, you can build your own LLM, or you can take a existing LLM and fine tune it to do your work. So, for example, I have medicines in India, and I just got around quarter million data. When I fine tune the existing LLM or my own LLM with this data, I can ask LLM about any medicine for in India for a particular need. It will come back and give a decent answer. And like that, I collected a lot of data which can be used. And also, I have given a section for LLM data sets. This is a Dolly, which is a nice data set um, created by the Dolly team, which is basically instructions, context, and response and category. If you have this kind of a data, this has got around um, around 15k into 10, so 150k items are there. So if we give this kind of instructions, and after it got trained, fine tuning this can be done on this kind of data. I'll also have a video, hands-on video how to fine tune existing LLM. So going back to autoregressive, my goal in this video was explaining how the original design was for the LLM, and how they have become more intelligent in doing things like chain of thought, React, as well as the tree of thoughts. And thank you.